Hi everybody, let's do lesson 10.4 today. Some more volume problems, no new formulas, so keep your whatever formula sheet you're creating for yourself there handy. We'll be using those today. We're going to look at two types of problems. The first two examples we're going through together are just problems where they already give you the volume and you're just solving for a particular measurement on the solid. So maybe you're solving for height, or maybe you're solving for the radius. Okay, we haven't done any like that, so I want to do a couple of those with you. Once we get through those, I will ask you to pause the video. There's another worksheet that should be on the Google Classroom. There's some volume word problems that I'd like you to try on your own first, and then you can come back to the second half of this video and watch kind of the video answer key. I'll work through those problems with you. Okay, so here's our first example. You can just write this down, make a little sketch if you'd like. We have the volume of a right triangular prism already. It's 1,440 cubic centimeters. We are going to find the height ourselves. Let's set up here. Okay, so as always, whether we have the volume or we're looking for the volume, we're going to start with our formula. Remember, capital B is the area of the base. Here are our two congruent parallel polygons as bases, those triangles. Okay, height is what we're looking for. So in this case, we know V. Let's plug 1440 in for V. In place of base area, capital B, we're going to put 1/2 base times height because it's a triangle. So 1/2 times 8 times 15, and then times h, our unknown height that we're trying to find. Okay, so let's just clean up that right-hand side. What's in the parentheses there, the area of that triangle is just 60. And then we'll divide both sides by 60 to get a height of 24. Now that's just a height, so not cubic centimeters, but plain old centimeters. Okay, so that's it. Nothing crazy with these problems. I just want you to be thinking about possibly solving for a different piece of the formula. In example B, this one's a little harder because of what shape this is. So they give you the volume again, 2,814 cubic meters. Find the radius of the base of the cylinder to the nearest meter. Now this is just a piece of a cylinder. If you remember, I can't see that blue on the blue there very well, that's called a sector. Okay, it's just a fraction of the total circle. So when we're talking about the area of that thing, it's just a fraction of the total area. So let's start plugging some things in here. For V, we'll put the volume that they give us, 2814. Now, capital B comes out, in goes a fraction of the total area. If you remember, that's our arc measure over 360. So how many degrees out of a possible, whoop, I don't know what happened there, 360 do we have? That tells us what fraction of the circle we're working with. So a fraction of means multiply, and then the total area would be pi r squared. Now we don't know r, we'll just leave that there. I guess I'll skip ahead one step here and plug the rest in again. Okay, so we do know arc measure. You can see it there in the picture. It's 40 degrees. And if you like reducing those fractions, great. If not, remember we talked about that's fine. There's no reason to miss the problem just because you don't like reducing the fractions or you're having trouble with that. Pi r squared stays there. The height, that's this 14 meters over here. So this one is just a little bit tricky algebraically. What I would suggest is, let's deal with the 1/9, the pi, and the 14. There's no addition or subtraction here, so there's really no need for those parentheses. So that's 2814. I don't know why I have degrees there, or whatever symbol there is there. Get rid of that. So 2814 equals, I can multiply all this other stuff that's underlined here. That whole thing, and I'm going to try to keep this number in my calculator, but is about 4.8869 or so, or squared. Okay. If you're comfortable using that answer button, great. That will help us avoid rounding error. So we're going to divide 2814 by this number, that decimal that's in your calculator. So do 2814 divided by the answer, and we get r squared is about 575.82. And then remember, we want not the radius squared, just the radius, so our very last step here is to take a square root. it's about 24 meters. Okay, about 24 meters. Okay, so that's just the first type of problem I wanted to go over with you because we haven't done anything like that yet. Now, before we can start the word problems, there is something else we need to talk about because we may have to convert some units back and forth here. So let's look when we're converting using volume, so cubic units. This was something we discussed when we talked about area. If you remember, let's talk about like 1 square foot, what that looks like. So let's imagine you had a square that is 1 foot by 1 foot or 12 inches by 12 inches. If I found its area in square inches, like think about this. So if I can fit 12 going across this way, I'd fill all that out, and 12 going across this way. The area of that in square inches is 144 square inches. That's the equivalent of 1 square foot. So when we're talking about converting between square feet and square inches, we don't divide by 12 anymore. We divide by 144. Similarly, but let's take it a step further here. If we're working with cubic foot, so 1 cubic foot looks like this. Draw a cube with me. And let's put the dimensions on there. So instead of putting 1 foot by 1 foot by 1 foot, I'm going to put 12 inches by 12 inches by 12 inches. Now let's think about the volume of that in cubic inches. Its volume, just think, area of the base times the height, or if you like, length times width times height for something like this, that's fine. It's 12 times 12 times 12. Let me write this out. 12 inches times 12 inches times 12 inches. That's its volume. That's 1,728 cubic inches. So 1 cubic foot is equal to 1,728 cubic inches. So if you're converting between cubic feet and cubic inches, that's the number you either multiply or divide by. 1,728. I know that seems a little bit surprising, but just think about this. So like if we broke this up into its layers of cubes, we'd be able to fit 144 on the bottom layer, and then there would be 12 stacks of that. Okay, and just imagine a little cube that's 1 inch on each dimension as opposed to 12 inches. That's quite a bit different in size. Okay, so you'll use that moving on to this worksheet. So you should stop now. Let me see, do I have them on the screen here? Go back to the worksheet on the Google Classroom. Try these 4 problems on your own first, but please come back and then check the answer key. Okay, so go ahead and stop now. Okay, hopefully you've come back to me now. So let's go through these together. Let me just give you the answer right away here, and then we will check. So it turns out that if you take this piece of paper, and I don't know if you considered trying this one, you can actually take a piece of paper and do this. Believe it or not, they have a different volume. The short fat cylinder, this one here, ends up having more volume. So that's just kind of surprising. It's the same surface area. It's all one piece of paper, but you can actually fit more stuff in it that way. Now, this one is a little bit challenging, so let's talk about this tall, skinny one first. If I think about wrapping it that way, I think it's actually easier to think about the height first. This would be 11. That means the 8.5, the other dimension, is wrapped around this way. That's the circumference of that base, which is great, but we want not just the circumference, we need the radius. So we're actually going to start here. So the circumference is 8.5. Okay, so we're going to use that. Whoops, 8.5 equals 2 pi r, and we'll solve that for r. So we're going to very carefully in the calculator divide by 2 pi. The radius is about 1.35 inches. If you're not getting that, just watch that you divided by 2 pi correctly. Okay, now we can calculate the volume. So we need area of the base, that's pi r squared, times the height of the whole thing, that's 11 in this case. Okay, so that volume is about 63.24 cubic inches. Now, if we compare that to the shorter one, its height, this is the 8.5, so now the 11, the dimension of the paper, that's 11, that's the circumference of this one. Okay, sort of wrapped around. And you can try it. If you're having trouble following this one, take a piece of paper, take the paper you're writing on right now. It's probably an 8.5 by 11. Roll it into these two different arrangements and see this happen. Okay, so in this case, the circumference is 11. We'll use that to find the radius. So circumference equals 2 pi r. Divide both sides by 2 pi. The radius is about 1.75. And then when we use that now to find the volume, pi r squared times our height of 8.5, you'll see we get, surprisingly, I think it's surprising, a different volume, 81.85 cubic inches. So significantly different volume as well. Okay, so that's number one. Number two, this we discussed in the video prior to this. So 1 cubic foot is equal to 1,728 cubic inches. We'll be using that in the next part of this problem. Okay, so we first need to figure out, to find how much this mattress weighs, we need to figure out how much water will fit in there. We actually want to find the volume first, then we'll worry about this weight, that it's 62.4 pounds per cubic foot. Okay, so we have the dimensions. This is just a rectangular prism. So we can either do area of the base times the height. I mean, that's kind of our standard formula, but it is fine to just do length times width times height for this. I'm going to set it up as area of the base times the height, thinking of kind of this big. So we've got what, 72 by 84 this way by this little height of 9 inches. Okay, so my base then is 72 times 84 times the height of 9 inches. So that volume in cubic inches is 54,432 cubic inches. So that's how many little tiny 1 by 1 by 1 inch cubes we could fit in there, but that does not really answer the question for us. We want to know how much does it weigh. In order to do that, we need to use this. It weighs 62.4 pounds per cubic foot. So we're going to take that number and convert it to cubic feet. Okay, so we take our 5, 4, 4, 3, 2. I'm going to set this up like we did with surface area with our little fractions. And I'm going to multiply by, now I want cubic inches to cancel out. So I'm putting 1728 on the bottom and 1 cubic foot on the top. So because that's on the bottom, we are dividing by 1728. So that is 31.5 cubic feet. Big difference there. Okay, big difference. So that's how many cubic feet we've got. Water weighs 62.4 pounds per cubic foot. Okay, so if we're talking about the weight now, we're going to take this, let me write it the other way first. Oops. Our weight of 31.5 cubic feet. We're going to multiply by 62.4 pounds per cubic foot. And we get a weight of 1,965.6 pounds. That's pretty heavy. But last little piece here, I don't know if you caught this, an empty mattress is 35 pounds. So we've got the mattress plus the water. So we're going to add to that 35 pounds. Here's our total weight, 2,000.6 pounds for that full mattress. Okay, applaud yourself if you got that one. That is a lot of steps, a lot of converting, a lot to really work through. So great job on that one if you got it. If not, don't panic. Just make sure you can kind of work back through those steps, piece that together. Okay, the next one here. We have just a cylinder storage tank, nothing too crazy here. We do have to figure out what to do about this 7.5 gallons per cubic foot. But let's start. Hopefully you found that volume. So the area of the base times the height, that is a circular base. So we want pi times 12.5 squared. Did you catch that? That the diameter is 25, so we want to cut that in half times the height of the whole thing. So the volume is about 1,000, nope, take that back, 14,726. I have 0.22. Now this one's already in cubic feet, so no need to convert there. That's its volume. Now we just need to know how many gallons will it hold. 1 cubic foot holds 7.5 gallons. If you get to this point, it is not easy to determine whether we multiply or divide. I think we probably know we need to do something with that 7.5. So I like to do this. Imagine that you only had 1 cubic foot. How many gallons would it hold? Hopefully you're thinking, oh, 7.5. If we have 2 cubic feet, how many gallons would it hold? That's 15. 7.5 times 2. We multiplied right there. So we're going to do that this time as well. So we're going to take this and we're going to multiply by 7.5 gallons per cubic foot. So we should have a pretty large number, but it is a giant storage tank. So hopefully that makes sense. So we're looking at about 110,446.6. If you said 447, that's fine. Gallons of water. Okay, if you have a much smaller number, because you divide it, it's a little bit hard to tell, is that a reasonable answer or not, because these numbers are so large. So again, just go back to what would 1 cubic foot be? What would 2 cubic feet look like? Or what would I do with that? I think that makes that easier. Okay, and then the last one here. This time we have a cone. We're doing something kind of similar here. We need the volume first, and we need to know how many truckloads does it take to build up this pile. Did you use 1/3 area of the base times the height? So let me give you the answer right now. It's about 57 trucks. If you have 3 times that, you forgot the third right at the beginning. Okay, so we're looking at 1/3 times pi r squared. The radius is 8.5 times the height of the whole thing. That volume is about 680.94 cubic meters. Now this time we know that, where is it saying here? Each trailer can carry 12 cubic meters. Okay, so each truck can carry about 12 cubic meters. This is a division scenario. Okay, it's hard to tell, are we multiplying or dividing, but we're going the other way this time. So we're going to divide by 12 cubic meters per truck. And we get 56.7, or let's say about 57 trucks. If you said 56.7, that's fine. Okay, that's all for today. Feel free to go back, pause, rewind, redo, fix your problems. You let me know if you have questions. Send me an email. Join me on a live session. You let me know if you'd like one. I'm happy to host one, but I'll wait and hear from you because I don't want to sit there if no one's going to join us or you don't have any questions. Okay, have a great day, everybody.